Okay, so hello everyone. My name is Richmond and I'm the founder of the RichTechWorld. Today I'll be the speaker and I'll be taking you through the introduction to robotics. Due to some inconvenience and some technical problems we're having, we pushed the time or we brought the time in front. Okay, so instead of us starting at 1:30, this meeting is starting now at 1. And because of that, most of the students won't be able to join. And also people that are in school now, I mean those who registered for this RTyoungStars who are in school now, um, may not be able to join. So as a result of that, this session will be recorded. Okay, so every single part of this session will be recorded, and all what we'll be discussing today will be posted at the RichTechWorld channel on YouTube. So right after this session, we are going to upload the video there so that if you miss anything, you can go there and have it. So without wasting much time, I would like us to start with the session. I understand most of you are not yet in, so we can't also wait for them because of our time. So let's start with today's session. Okay, we are going to talk about the introduction to robotics, and I'm going to share my screen. Okay. Okay, so I hope each and everyone can see my screen. Today we'll be talking about robotics. I mean, introduction to robotics, and this is the outline I have for this session. Okay, we are going to define, or we are going to have the definition, and due to our time we'll be talking about some of the things in the outline. We wouldn't be talking about everything. Okay, so we'll be talking about the definition, types, uses, history, and key components for today. Okay, and with the application future and whatever we have next, we'll talk about that in another session in the future. Okay, so for today's introduction to robotics, we are going to talk about these few things I said up to the key components. So without wasting much time, let's just start with something. Okay, so first of all, I would like it to talk about something. Okay, discuss something before we move into the PDF I have here. Okay, and after this session I'll have the PDF posted in the group so that if you want to further do your own research, you can use the PDF as a guideline. Okay, so let's start. Now, robotics is the intersection of science and engineering to produce machines called robots, okay, to help you know human or mimic human activities. You understand? So that's basically the definition of robotics, okay? And there is a difference between robotics and robots. So the next thing I want you to know is what robots are, okay? And robots are just programmable machines built to assist and or mimic human actions. Okay, so it's through robotics that we have robots. So that is what you have to understand the differences. So robotics is the word intersection of science and engineering and technology, whilst the product of robotics is what we call robots. Okay, so let's talk about um, um, we are going to talk about some of the functions of robots. Okay, so assisting in the construction of cars, fire fighting, cleaning homes and all. We have so many functions, and then we have so many types of robots, and we have their functions as well. So let's move back. In the PDF we'll talk about the history of robots, but then I want you to know that in 2005, 90% of robots were found manufacturing cars. So when you move to those manufacturing companies like Toyota, Benz, in 2005, most of these companies were those that were using robots, okay? And those are stationary robots, robots that don't move. You go to the types of robots and you understand the types too as well, okay? So those robots were mostly used for welding, carrying heavy machineries in manufacturing these vehicles, okay? So that was it for that. And We also talk about what robots consist of, okay? And then right now, I just want to give you a gist. We have mechanical aspects, we have the electronical aspects, and we also have the computer programming. So these things are things that comes together, or if you take a robot in general, these are things you have to see in that, okay? And note that without a code, a robot will also be a simple machine. Okay, without a code or program, robots are just simple machines. So right now, let's move into what machines too are. Okay, so machines are electrical or electrically operated devices for performing tasks. You understand? So the difference between simple machines and robots is just because robots are programmable. Okay, robots can take certain decisions by themselves without the help of a human. You understand? But with simple machines or normal machines, you have to give every instruction live. You understand? You push a button for an action to be done. That's what we call simple machines. Okay, you understand? Okay, so let's move into the slides I have here, and let's also talk about. Okay, I think my camera is off, so let me turn on my camera. Okay, so you can see me now. Okay, so robot definition. Okay, so this is what we have. World robot was coined by a Czech novelist Karel Capek in the 1920. You understand? So in 1920 was the time robots were developed or brought into place. So this is something simple you need to understand. Okay, so let's move to the definition of the robots I have here by this PDF. Okay, any machine made by one or okay, so I think the second line is what is talking about what robot the definition of a robot. A robot is a reprogrammable. You see the key points there, and I want you guys to note those ones. Okay, robots are what? Reprogrammable, multifunctional manipulators designed to move materials, parts, tools, or specialized devices through variable program motions for performance of a variety of tasks. You understand? So when you move into a manufacturing company, for example, Toyota like this, you have robots that are meant for welding, robots that are used in carrying some parts, robots are used in taking the engine into the car and all. You understand? So robots are multifunctional and also they are reprogrammed. Okay, so they are given instructions to go by, unlike simple machines. So this is something basic you need to understand. So let's move to types of robots. Okay, so we have manipulator. Okay, this is a type of robot, and this type of robot is those we have examples to be the welding machines we have, or the welding robots. Sorry, welding robots. We have Kantanka in Ghana here has one, and for welding some of his car parts. Okay, so these robots fall under stationary robots or robots that do not move. Okay, so that is that. And we also have legged robots. Okay, so I want to let you guys know the world first intelligent gaming robot, okay, called the Mikamon, was a robot built by an African, and he's a Nigerian. Okay, and this is something great for Africa. Okay, so this robot has legs. Okay, just like the legged robot. You can go and research on it. It's called the Mikamon, and I'll type it in the description so that sorry, the chat, so that you get it. So let me type it right now. Mikamon. So this is it. Okay, so Mikamon. And then we also have wheeled robots. Okay, robots with wheels. Okay, so that is that for that too as well. We also have autonomous underwater vehicles. Okay, these are mostly used by the those who do research underwater, and also the those who use submarines and all. We also have unmanned area vehicle. unmanned area vehicle. And the unmanned area vehicle example is the drones we normally use. And drones are robots. What makes drones robots? Okay, drones, have programs they go by. They are programmed in a way to fly, to be able to balance themselves in air. All what we do as human beings when we are controlling our drones is just to move it up, move it forward, move it left, and what have we. But what happens if the air blows the drone in a way that is unbalanced? That is when it comes in with its programmed, intelligence. It's programmed intelligence. What I mean is, in case the drone is in air and it encounter any air, it's going to change in direction or it's going to lose control. So with this, the drone has been programmed in a way to balance itself with some sensors. For example, the gyro sensor is able to measure the angle the angle of tilt of the drone. So if it's reads any angle that is not supposed to be read, it can sense those things and then send the message to the microcontroller to balance the robot with the help of the actuators, which is the propellers and the motors. Okay, so that is that for drones. I want everything to be quick. Okay, so let's move to the uses of robots. Okay, so jobs that are dangerous for human beings. Okay, like mining. When you move to some companies, even in Ghana, I think there are robots that helps in mining. Okay, um, um, those who disable bombs. Okay, those who disable bombs. They also use robots in doing that. So those are very dangerous works that if you make a normal human being, or if you tell a normal human being to do, the person will have fear. Okay, but robots are given instruction and they do nothing apart from the instructions they've been given. Okay, so cleaning the main circulating pump, housing in a cleaner, and also robots are um able to, the welding robot I was talking about, which Kantanka has some here in Ghana. I know, and I'm also sure that there will be some companies that will be having this kind of robots. Some works like, cleaning bathhouse and or scrubbing, works that human beings wouldn't like to do. You understand? So these jobs are done by robots. Okay, yeah. So we also have some laws of robotics. Okay, so when you are a robots developer or you are a robotics engineer and you are building a robot, you should make sure that your robot goes according to all the laws of robotics. Okay, and these are the laws that as human beings we have laws or constitutions that governs us so that we wouldn't go wayward. And with robots, they are machines, and since sometimes most of them are dangerous, you have to give them some laws. Okay, and these laws are, we have one, the law zero. A robot may not injure humanity or through inaction allow humanity to come to harm. That is the law zero. And the law one says a robot may not injure a humanity or through inactions allow a human being to come to harm unless this would violate a higher order law. Okay, the law 2 also says that a robot must obey orders given to it by humanity or human beings, except where such orders would conflict with a higher order law. Okay, and the last and third law is a robot must protect its own existence as long as such protection does not conflict with a higher order law. Okay, so these are the laws of robotics, and these are the laws robots must go by. Okay, so if you're a robot manufacturer, you are building robots for your company or whatever, or a company industry or whatever, you should make sure your robots go by these laws. Okay, so history of robotics. So as I said earlier on, we will talk a little bit about the history of robotics. Okay, so the first industrial robot is called the Unimate. Okay, so it was built in 1954. It was the first programmable robot, and it was designed by George Devil, who coins the term universal automation. He later shortens this to Unimation. Okay, so that is that for that too. So let's move on. So these are all histories, and due to time, I wouldn't be going through all of them since I'll post the PDF in the group. Okay. So yeah, then we moved on to that. Okay, so this is a robot NASA built in 2003 for Mars exploration. Okay, and I know most of you will know about that. So knowledge base for robotics. Okay, typical knowledge base for robotics design and operations of robotic systems. Dynamic system modeling and analysis. You understand? Feedback control, sensor and signal conditions, actuators and power electronics. We also have hardware or computer interfacing and computer programming as well. So some of the disciplines we used in robotics is just mathematics, physics, it's science. You understand? Mathematics, physics, biology, mechanical engineering, electrical engineering, computer engineering, and computer science. Okay. Now, someone will say, why biology? Because this is all calculation and all. No. Okay. When you move to biomedical engineering and all, people build robots, and currently I think there is a robot that helps in surgery. Okay, so if you are building this type of robot and you have no idea in biology, how are you going to build it to solve this particular problem, health problem? Because it's it's centered on biology. Okay, so this is that for that. And then key components. Okay, key components. So for now, I would like you to understand the controller, the sensor, actuator, how they work hand in hand. So the sensors what sends information to the controller, okay, and then actuators also receive information from what the controller. You see how the thing goes, okay? So for instance, I'm going to share another screen here for you to see um, the the okay. Okay, so we will do that later on, but let's move on. So all what you need to understand from this part is that the sensors sense what information. So with robots, what makes them robots is because they are able to sense some conditions. For example, you have temperature sensors, you have ultrasonic sensors for distance, infrared sensors. You have so many sensors that are fitted into robots for them to know the condition around them. Okay, and with those conditions, they are sent to the microcontroller, and the microcontroller takes decision based on how it has been programmed and sends whatever it has to sense to the actuators, and that is also based on the program. Okay, so that is the main thing you have to understand. And the user interface is how the user interprets or communicates with the microcontroller. So let's move on. Let's move on. um So yes, I was talking about stationary robots and also fixed robots. So robotics or robotic manipulators used in manufacturing are, example, the fixed robots, they cannot move their base away from the work being done. Okay, for example, these welding robots. Sorry, I say machines instead of robots. Pardon me for that. Okay, so these robots do not move. Okay, they can't move on their own. They mostly work with their arms, or their movable parts are only the arms. Okay, so that is that for that. And an example, if you want to see some of these machines, or sorry, some of these robots, you need to go to the automobiles. Okay, those um, factories or industries that manufacture cars or vehicles. That is where you are going to see most of these things. Okay, so mobile base, because we've talked about the fixed, let's move to the mobile. So the mobile bases are typically platforms with wheels or tracks attached. Okay, so with these robots, they can move from places to places by themselves. For example, the Mikamon I was talking about, which was built by Silas Adekunle, a Nigerian, also from Africa here. Okay, it's a robot that has, you know, legs, and it looks more or less like a spider. Okay, and it's a gaming robot. This robot can move from places to place with its legs. We also have robots with wheels, and people, companies like the Boston Dynamics, they also produce robots with you know, 4 legs, okay, that can move with them. So those are a few examples. So let's talk about the robot mechanism, okay? Robot mechanism. So with what I said earlier on, before I started moving into this slides, I spoke about mechanical aspects of robots, okay? So let's break these things down. So when we talk about the mechanical aspects of robots, we have um, the gears, that those are mostly the actuators. So when we talk about the actuators too, actuators are those who perform actions. They take instructions from the microcontroller and perform actions. So these actuators fall under the what? Mechanical aspects of robots. We also have the electrical aspects of robots. When we talk about the electrical aspects, we all know um, components of electronics. Okay, sorry. So when we talk about the electrical aspect, we can talk about components like the microprocessor itself, the capacitors, the resistors, you know, the interface, and those stuff. So those things fall under the what? The electronic components. The electronic components. And we also have the programmable part, or the computer programming aspect of robotics. That is when you instruct your robots to perform tasks. So that is when you program, or you give the robot a program to, you know, go with. Okay, so that is it. So what I want you to understand is these things can be classified into three main things. So if you pick any robot at all, you should find these three things on them, which is firstly the actuators, which are the mechanical aspects. Okay, so the actuators, the moving parts of the robots. Okay, and then the second one is the microcontroller. Okay, the part that processes all the information, or based on the program you've given it. Okay, and then we also have the sensors. So the sensors sense information, and based on the information they've sensed, they send them to the microcontroller. The microcontroller also do some processing with that information based on the program. Okay, then it instructs the actuators to perform tasks or whatever they have to do based on the program as well. So let's move on. Let's move on. So yes, we have the senses. We have, okay, so let's talk a little bit about the human senses. Okay, we have the sight, sound, touch, taste, and smell. So you see, robots basically, you know, perform just like human beings, because with a human being you have your senses, okay, and you see, you're able to walk with your legs because of your eyes. So you see something, you know that you are not blocked, there is no obstacle in front of you. Okay, that information is sent to the brain, and the brain controls the legs. Okay, so yes, that is how robots also work. It's very easy and simple. So let's talk about some robot senses. We have so many sensors, and we are going to talk about them. Okay, so we have vision sensors, sensors that helps the robots in vision. Okay. Mhm. We also have force sensors. Example, pass fitting and insertion. Force feedback is in robotic surgery. Okay, so those are the force sensors. We also have proximity sensors. Proximity sensors, and you can see here that down left, okay, down left we have an ultrasonic sensor here for, you know, sensing obstacles. Okay, so people build up obstacle avoidance robots with ultrasonic sensors. So how these, okay, so I have um let me show you this. Okay, let me share my screen with this one. Okay, so with what I'm going to share right now, you are going to basically see all what these thing, all what I'm talking about, okay? As in robots consisting of the microcontroller, the sensors, and then the actuators. So with this particular robot, we have four DC motors, which is motor 1, motor 2, motor 3, and motor 4. And then we have one servo motor. Okay. So all you can see all the components are connected to what? The microcontroller, or the what's the name? The processing unit. Okay, so this is where everything is processed. This is where the program is, and this is where the robot is, controlled from based on the program on it. Okay, so we have ultrasonic sensor. So when you see anything and you want to differentiate it from a simple machine, you should know if that particular thing is okay. Sorry, you should know if that particular thing is a robot or not. Okay, based on what I've just said. First of all, the key thing you have to notice is that thing programmable? Has that thing been programmed? Does that thing take some decisions by itself? If no, then it's a simple machine, or it's a machine falls under unprogrammable machines. For example, you see, we have cars that we normally use in Africa here, but then you've heard of Tesla self-driving cars. So these normal cars falls under normal machines, and these self-driving cars by Tesla are those that can be classified or grouped under robots. Okay, so we should try and understand those things, because with Tesla's car, it can take some decisions by itself. It can avoid obstacle by itself without no driver. It can work. So you also have tilt sensors, okay? Sensors that helps robots in balancing themselves. So I made mention of one of it. I made mention of a gyro sensor, which is mostly found in um, drones, okay? Gyro sensor or gyroscope, they are mostly found in drones. Okay, so those sensors helps drones to balance themselves, has axis where it reads axis in different directions and dimensions, you understand. So when there is any reading, it sends the message to the microcontroller for the microcontroller to know how tilted the robot is, I mean the drone. Okay, and if there's any correction to be made, it gives power or distributes more power to some of the propellers to help the drone to balance itself. So this is a simple explanation that will help you understand the tilt sensors. We also have actuators. Okay, I've already spoke about the actuators. We have so many types of actuators, and I said those are the things that perform the actions. Okay, they perform most of the actions. We have hydraulics motor, we have the pneumatic motor, we have DC motor, we have stepper motor, we have servo motors, we have muzzle wire, we have the pneumatic motor. I think we said that here. Okay, so let's move on. So let's talk a little bit about controllers. Okay, so we've talked about sensors, we've talked about the actuators. So the last thing we need to talk about is also the um, controllers. So these three things are the main, they are not the only things that form or constitute a robot, okay? But then they are the main things we need to know about robots, because without them, robots are not robots, okay? So sensors, we spoke about them, spoke about actuators, and the next is the controllers. So let's talk about them. Provide necessary intelligence to control them, manipulator or mobile robot, okay? Process the sensory information. Okay, so I made mention of this, and compute the control command for the actuators to carry out specific tasks. Okay, so for example, um based on what we've just read, okay, what is this particular statement of few lines of words says that the robot would, or the controller would compute or process information. The sensors are sent to it based on the program or command given to it by the manufacturer or the designer, okay, and then sends the rights or sends a command to the actuator to perform a specific task based on what the programmer or the developer gave to it, or the program the developer gave to it. So it's very simple. So let's break it down for us all to understand. Let's take a simple example of an automatic dustbin, okay, or a hand sanitizer. Okay, a hand sanitizer. Let's take that one. Okay, so what happens in this hand sanitizer? So let me talk about the main component that makes up this hand sanitizer. We have a sensor that senses obstacles. So let's use ultrasonic sensor for that. So that is one. So we have the sensor. So what is the actuator? So you know that hand sanitizer is, we mostly press it for, or we need to get the sanitizer out of it. So how do we get that? Just like a motor, okay? So the motor will fall under the actuators, okay? And the last thing we'll talk about is the controller. So these three things are what we really need in making this particular hand sanitizer. So how does this work? The hand sanitizer is programmed in a way that when the sensory information, or the information received from the sensor meets a particular condition, then the actuators should perform a specific task. Okay, so for instance, if the ultrasonic sensor senses a distance less or equal to 10, then the actuators or the motor should what? Rotate for the sanitizer to come out. Just something like that. The same applies to automatic dustbins, okay? Those dustbins that opens automatically by itself. So these dustbins are also programmed in a way that when the sensors sense a particular reading, it sends a message to the um, the microcontroller, and the microcontroller also commands the actuators to perform some task. So we also have storage device, because with all these microcontrollers, they need to store the program. The program that is running on it needs a space to be stored. Okay, so we have storage components. Okay, we also have computational hardware, computational engines that compute the control command. Okay, so that is that for that. And we also have the interface hardware. Interface hardware. So I'm going to show you an example. So I'm going to stop sharing the screen and I'll show you. Um, I'm going to stop sharing my screen. Okay, so let's take this microcontroller for instance. Okay, this microcontroller has a USB interface right here. So the squared black thing on top of the ash thing here, I'm pointing, the black thing on top. So that is the USB interface. So what is this USB interface? What it basically does is it just translates the signals from the USB port, or the signals the USB port is receiving, into signals the Arduino microcontroller understands, okay, or signals for the Arduino microcontroller to be able to work with. Okay, so basically it's just like a translator. Okay, so we have analog to digital converters. Okay, we have operational amplifiers, and all those are all interface. And the one I mentioned is called the USB interface. That is for the Arduino Uno. Okay, so today this is what I want you to understand for today. Okay, and in our next meeting we would talk about the Ev3 hardware. Okay, so we take one particular robotics kit. Okay, and if you're a robotics, if you want to be a robotics engineer, or if you are learning robotics, you have to start learning robotics with these um, these small kits. Okay, so for instance, as I said earlier on, the Ev3 kits is very good. You can start with Quacky, then you start migrating to the Arduino and Raspberry and all those stuff. So you start little by little. And with robotics, it involves a lot. It involves the construction, electrical, and also the programmable aspects. Okay, so with the EV3, it's mainly going to help you with the building aspect or the construction aspect, and it will also give you a little knowledge or a simplified knowledge when it comes to the programming. Okay, so when you move into the Arduino or the other robotics kits we have, then you will learn also more about the electronics. Okay, so that will help you in robotics. So I think we will be ending the meeting shortly, and that is that for today. And I will post the PDF in the group for all of us to get access to it. Okay, so thank you all, and we meet tomorrow.